Okay, the last part of 6.4 has to do with conversions, changing rectangular equations to polar equations and back and forth. And we're looking at the domain being all the values of theta, where you have a real number r. And when we graph polar, we need to select what the theta min and the theta max is. So let's go through these examples. Alright, so in the first example, we are actually looking at converting from r equals 4 secant theta to a rectangular form and identifying the graph. So the first thing I'm going to do is write down the problem. The second thing I'm going to do is get the 4 by itself. So I divided by secant theta. Now, do you recall that 1 over secant theta equals cosine? So I'm going to substitute 1 over secant theta to be cosine. Now, what does our cosine theta equal? Well, back when we were looking at our conversions and we had the triangle x, y, r, and theta, we said that x equals r cosine theta, just by doing the old SOHCAHTOA. So I substituted that in for x. Now when you look at it, you've got a vertical line. It is a vertical line through x equals 4. And we're used to seeing it rectangular. If we drew this in polar mode, we would have a vertical line. Now the next example is converting. This is actually has the form of a circle. It's centered at the point 3 and negative 2. Or 3 and 2 rather. And the radius happens to be the square root of 13. So now what we have here is we're going to expand this. There's no other way to do that. So I'm going to FOIL it out, and I get x squared minus 6x plus 9. And this one's y squared minus 4y. This is a minus. Plus 4 equals 13. And I'm going to add some like terms. So what I've got here is I'm going to put the x squared plus the y squared together. And I put the minus 6x and the minus 4y. 9 and 4 is 13, and that cancels out that 13. And now what I've got here is this equation. Now I'm going to now look and see if I can change it to polar. If I recall from my triangle up here, x squared plus y squared is r squared. And I'm going to change the x to r cosine theta, and I'm going to change the y to r sine theta. So now what I've got here is r squared minus 6r cosine theta minus 4r sine theta. And they all have an r, so I factor it out. And I'm left with r minus 6 cosine theta minus 4 sine theta. Well, if I take r equals 0, that's just the point right at the, it's the center of the circle. And then I set this equal to 0 and solve for r. And this is the polar equation of a circle, of this specific circle. Now, how are we going to use polar coordinates in application problems? Well, here's an example 7. Radar detects 2 airplanes at the same altitude, and their polar coordinates are 8 miles, 110 degrees. It doesn't say anything about bearing. So if that's the case, then we're looking at from the standard x-axis and not from north. And the same thing applies to 5 miles, 15 degrees. How far apart are the planes? So what I'm going to do here is I'm going to first draw my picture. So I went 110 degrees, and that's 8 miles. And I went 15 degrees, and that's 5 miles. And I want to know what's this angle here. So I took 110 minus 15, and I got 95. Now I have this triangle. Now, I don't know if you recognize the triangle, but I have a triangle that does this. I have 95, 8, and 5. And I need to know this distance. I have no idea what it is. But this is side angle side. I don't have another side to use the law of sines, so I have no other choice but to use the law of cosines. I cannot use Pythagorean theorem or SOHCAHTOA because this is past 90 degrees. So I set up my law of cosines, plug in my values, AB minus 2AB cosine of C. And when I plug it in my calculator and take the square root, I find that the airplanes are 9.8 miles apart. You should now be able to get started on 6.4. There are two parts to it, A and B. You can start it Thursday night. You can start it after your quiz. Friday, you can work on 6.4. I'm also going to have 6.5 video up, so if you want to look at that, you can do that as well. And next week I will be back on Tuesday, so you will be working on 6.5 on Monday.